Did you know degrees were once measurements? Did you know that squares of the triangle were originally measurements also? Did you know that you don't study the many circles of the ball, so you don't figure out that the false pi that they teach is wrong? You don't study the circle as a whole, so you'll never stumble upon the 3.6-inch circumference circle, or the circle where the diameter is equal to the square root of 4/3. Degrees were once measurements. If you multiply the diameter by pi, it will always equal where 360 degrees is. If you multiply the 60-degree position by pi, it will always equal where 311.76914,536 degrees is. When you multiply the 30-degree position height by pi, it will always equal where 180 degrees is on the main circle every time. You're looking at the true 3.6-inch circumference circle. Whenever you multiply the diameter by pi, it equals 3.6. Whenever you multiply the radius by pi, it equals 1.8 inches. Whenever you multiply the 60-degree position by pi, it equals 3.1176914,536. Now let's bring these inside diameters of the ball to life. Listen carefully. A lot of information. Do you see the 30, 60, 90 right triangle? The hypotenuse is the diameter. The opposite side is equal to the radius. And the adjacent side is made from the 60-degree portion of the ball. Now the circumference made from the radius is 1.8 inches. The circumference made from the adjacent is equal to true pi. 1.8 inches squared plus true pi squared equals the biggest circle, 3.6 inches squared. And the area of this circle plus the area of this circle equals the area of the biggest circle. And whenever the diameter is 1 inch, the radius is 0.5 inches. And whenever you square 0.5, you get 0.25, which is this section of the circle and 1/4 of the hypotenuse diameter. And whenever this is 1 and this is 0.5, the adjacent is 0.8660254,038. That's this link right here. Whenever you square this side, you get 0.75, 3/4, and that is this section of this circle. So you see, originally the squares were measurements and portions of the circles inside of the ball. And that's why you can square the sides and it